Hey gang, supply-demand equations. This could be a short video. This usually turns out to be a type of a problem that students don't do well on. And there's a lot going on here, but there's not that much compared to things that we're going to get on later in the semester and you guys will find out there's a lot going on, but you'll get very good at those types of problems. For some reason, students tend to struggle with this type of problem in finite math. So maybe presenting this as a video will help a little bit. I don't know. What we have here is we have a situation where at a particular price, $1.88 in this situation, we have a supply and a demand amount given for cherries in a very large city. When the price drops to $1.46, the supply decreases and the demand increases. And I think the relationship between the demand for a product and the supply that we have on hand varying according to the price of a particular object, makes a lot of sense. What I want to be able to do here is I want to run through this with you and show you how to find the price demand equations. We're assuming they're both linear, and then we want to find this equilibrium point. The equilibrium point turns out to be the place where the demand and the supply functions, so the demand and the supply are equal. So we're going to end up with a particular quantity and a particular price where this phenomena occurs. You know what? Let's just jump to it and let me show you how this all kind of plays out. So again, let's think about this through kind of intuitively. At $1.88, you can see that you have a supply of 16,000 pounds. But when the price drops to $1.46, notice that the supply decreases to 10,000. And again, that relationship between price dropping and the supply decreasing should make a lot of sense. I know when I was in the golf business, and I'll talk about this quite a bit, if if I had drivers for $500, I had a certain amount of inventory, but if I dropped those things to $300, I sold more, so my supply would actually decrease. So and of course the demand would increase as the price drops. So guys, let's play this out. What we got a couple of things going on here. Okay, so first and foremost, what I'd want I'll show you that in just a second. First and foremost, what I would want to do here is I'd want to organize my work so I can put this in the calculator. So I'm going to have a particular price, and this is going to be a little bit confusing the way this is going to play out, because although I'm putting price first, we can see the way that we've drawn our graph here, we want price to actually come second. But nevertheless, when we have a price of $1.88 versus a price of $1.46, we know that the supply is 16,000, and we know that the demand is 10,600. When the price is $1.46, the supply decreases to 10,000, and the demand increases from 10,600 to 12,700. Now what we got to do is we've got to take this information and we have to think about kind of two phases, if you will, that we want quantity and price to represent our X and our Y, keeping in mind that our ordered pairs are always in the term X comma Y. Now the way I've done my chart up here, the price is coming first, but because the prices are Y here, we need it to come second. So ultimately what we have, the ordered pairs, for twofold for the supply. Are 16,000, $1.88, and 10,000, $1.46. For the demand, we have 10,600 of $1.88, and we have 12,700 for $1.46. Okay, so once we get that done, the things that I've shown you on the calculator in terms of finding the linear functions should be very easy. Now, I've got this, I'm going to use a little different approach here. I've got this downloaded on my computer, and I'm going to bring this up. So the kind of cool thing about this is the keystrokes are going to be simpler. So if I go to Stat and just hit Enter, and I have L1 and L2. So the first thing I want to do is I want to do this for the supply. So I'm going to have 16,000, and the other was 10,000. So I'm not worried about the demand function just yet. I'm just going to worry about this right here. Now, for 16,000, we know that the price was $1.88. And for 10,000, the price was $1.46. Now, just like before, we'll go second function quit. Go back into Stat. Go over to Calc, come down to number 4. Now, this is a little different, and this is exactly the reason that I wanted to show it this way. Depending on the operating system in your calculator, this linear regression AX plus B will come up differently. Now, this is a newer operating system than the calculator that I showed in previous videos. But nevertheless, it's probably easier because XList needs to be L1. Again, those are gotten from access down here between 1 and 2. All right. Frequency list, we don't have anything, and we don't need to store it. So really all we need to do is just come down to calculate. Now, what I've got here for my supply is I can say that my price is equal to, now that's 7. Now this is interesting, guys, and I didn't realize this was going to happen, but I'm glad it did. This is in scientific notation. It's going to be tempting to just put a 7, but this E-5 says that we have to move the decimal place 5 places to the left. So ultimately what this means is that we're going to have 0.00007 by the time we move this decimal, because the decimal right now is to the right of the 7. Move it 1 time, it comes to the left of the 7. Move it 4 more times. We fill in with zeros. So our supply is going to be the function that I just wrote at the bottom of the page. Now the next thing I want to do is the demand, and as we look back to the original game plan, we knew that the price supply was going to have a positive slope because it raced to the right. But the price demand, because of the nature of it, as the quantity increases, our price is going to decrease. Then we're expecting a negative slope. So it's still not a big issue with our calculator. So all I need to do now is just go into Stat and go to Edit. And the only thing I really need to do is just put in the quantity for each of the price. So for the demand, it was 10,600. and the quantity at $1.46 was 12,700. Okay, so keep the same prices. So again, let's go stat, go over to calc, come down to number 4. L1, L2 is where we have our information. And let's do calculate. Now, same thing here. It gives us scientific notation. Now, guys, there is one way we can, if this kind of annoys you, something you can do is you can come into mode. And, well, it actually has float and it has normal. So, yeah, really, I guess that's really about as good as we can do. So let's just go ahead and just get used to the scientific notation. Doesn't show up a lot, but shows up some. So guys, here we have -2 and -4 says again, move the decimal place 4 places to the left, put in 3 zeros. So our price is going to be -0.0002 x plus 4. All right, so let's minimize this, let's maximize that, and down at the very bottom you can see that we have our price supply function, or price supply equation, and we have a price demand equation. Okay. Now, I think it'd be really good to examine this, and let's examine it graphically. So, paying close attention to the number of zeros and all that kind of stuff. Let's go back in here and let's go to y equals. And I want to put in 0.00007x plus 0.76. And I want to show you a function here that can, on your calculator, that shows how to find the intersection of two lines. Comes in really handy here because of the equilibrium point is the intersection of the two lines. Now, guys, here we're going to start something with a negative. You got two negative signs. You've got this one and you got that one. Long story short, you never, ever, ever start a mathematical statement with this. This is a subtraction, 2 minus 5. If you start something with a negative, it'll always be that. So we want 0.0002x plus 4. Now, what you got to do next is you've got to get your, and probably the most important thing I'm going to tell you on this whole video is right now, so hopefully you're still with me. The most important thing you got to do is you got to get your window set up for this particular problem. Now, it's going to be a big issue once we get into linear programming, but it's a big issue for this too. So what I've got to do is I've got to go down here to Window, and I've got to think through my problem. Now, what did my x's look like in this problem? Well, my x's look like this: 16,000, 10,600, 10,000, and 12,700. So I know that I need to, I'm thinking 10,000 is my lowest x. So I'm going to set my x minimum something below 10,000. And 16,000 is my biggest x, so I'm going to set it just a little bit above 16,000. My prices deal in the $1.88, $1.46 range, so I'll use that to my advantage, okay? So when I set up this window to make it work for my problem, my minimum x I'm given in this problem was 10,000, so I'm going to come just a little bit below that. It's say something like 9,500. My maximum x that I have in this problem was 16,000. Since I came 500 below the minimum, I'm going to be consistent and go 500 above the minimum. Guys, x scale will always be 1. Now my y's in this problem were $1.46 and $1.88. Well, gang, I'm going to go just a little bit below the $1.46. And I'm going to go just a little bit above the $1.88. You could have used $2. Be fine. Nevertheless, I've got my window set up appropriately according to the numbers that I've got in this problem. So now I can hit graph. And what will happen is I get an intersection that kind of makes sense. Now, a really cool feature on the calculator, if we got two lines like this and we want to find the intersection, what we can do is we can go second function. Right up here we have a function called calc. It's right above the trace button. And if you come down to number 5, you'll see that there's an intersect function. So I'm just going to hit the number 5. And what this will do is it will let me take two lines and find the intersecting point. Now, the function is set up here for more than one curve. Say we had 5 curves and we wanted to isolate on 2. But it gives you the option of choosing the 2 lines so you want to find the point of intersection. But since we only have 2, that's redundant here. So I'm just going to hit enter. And I'm going to hit enter again. And the guess is irrelevant because linear functions can only intersect in one point unless they're the same line. And I keep hitting select until I get to the point where my screen shows intersection. So guys, what I know now is this graph that I gave you early on crosses at 12,000 and $1.60. So 12,000 and $1.60. So going back to this, I can see that my quantity of 12,000 gives me a price of $1.60, so my equilibrium point will be 12,160. That tells me that when the number of pounds of cherries is 12,000, the price is $1.60. More importantly, it tells me that the equilibrium, that the supply and the demand are going to be equal at that particular quantity of cherries produced. So that's kind of ideal when you can come up with the number of pounds if you really cared about cherries, and I don't think any of us do. But if you come up with the number of pounds that has a corresponding price, that what you supply, there's going to be equal demand for the supply on hand. So, guys, we call that the equilibrium point. It's one of the, I don't know, more confusing. It's I tell you, it seems to me that this thing should be set up where price is on the x-axis and quantity is on the y-axis, but that's not the way it works. These things are always set up where the price is your dependent variable, because it looks like to me that price drives the supply and demand, but that's not the way these are set up. The supply and demand actually drive the price. Okay, so I guess it's well, it is what it is. All right, now gang, what I want you to do for next time before we come up with the next video is going to be on exponential functions, but just to make sure that we're connecting, I have 2 problems here that I want you to try between now and then. This video was kind of short, so it gives you a little extra time maybe to try these. I'll work these when we start up the next video. So